So, good evening everyone. My name is Ken Masakyan. I'm going to represent uh, activity activity 2, design a circuit using diode only or combination of diodes and transistor. So your calculation and simulate using multisim or Tinkercad. Use slope or bulb to represent the output. So I'm going to use multisim. This is for the OR gate. So first, let's simulate the multisim. So as you can see, this is an on already, and the lid is not on. As you can see here for the OR gate, this is also in the diode. So the switching is here. Diode, the lid is not on. So I'm going to close. I'm going to close now. Or diode, 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 and the lid is now on. So for the next one, it's close, close on, close on. Let's close first diode 2, then open diode 2 and close diode 1. As you can see, the led is on. So for the next one, for the last one, it's gonna be close, and the lid should be open on. So here I'm going to uh, close diode 2, and as you can see, the lid is still on. So that's for the OR gate. Now for the AND gate, here's the truth table of AND gate. As you can see, it's off. So the circuit is here is already simulating, and switch 1 and switch 2 is off. And going to the diode 1 and diode 2. As you can see, the probe is still off. So now for the second one, it's gonna be on. Let's turn on switch 2, and as you can see, probe is still off. Now for the third one, it's gonna be off, and the probe is still off. So let's off switch 2 first and on switch 1. As you can see, the probe is still off. Now for the third one, for the last one, it's gonna be on, and the probe is going to off. Okay, it's going to turn on. Let's now turn on switch 2. As you can see, the probe turned on, and that's for the logic gate truth table using diodes as switch. So now for the NOR gate truth table is here. So the circuit is here using transistors as switches. So let's start the simulation. For the first one, it's going to be off, and the probe is going to be on. So let's off switch 1 and switch 2. So switch 1 for transistor 1. Let's off and off. As you can see, the probe now is on. So for the second one, it's switch 1 is off, and switch 2 is on, and the probe is going to be off. So for switch 2, let's on switch 2. As you can see, the probe turned off. And now for the third one, it's going to be switch 1 is on, and switch 2 is off, and the probe is still off. So let's off first switch 2 and turn on switch 1. As you can see, the probe was turned off. And for the second and for the last one, it's going to be on, and the probe is still going to be off. So now let's turn on switch 2. As you can see, switch 2 is now on and the probe is now off. And that's for the NOR gate using transistors and switches. Now for the NAND gate. So NAND gate is going to be this in the table. So first is gonna be 0, 0, 1. That's gonna be off off. So as you can see, this is the circuit for the NAND gate. And I'm going to off first, off switch 1 and switch 2. As you can see, they're all off at 0, 0, and the probe is on. So now for the second one, it's now gonna be off on, and the probe is still gonna be on. So I'm going to off on. I mean, yes, off. Switch 1 is still on, and switch 1 is still off, and switch 2 is gonna be on. So switch 2 is now on, and the probe is now on, still on. So for the third one, it's gonna be on, off, and the probe is still gonna be on. So I'm going to off switch 2 first. I'm gonna off switch 2, then on switch 1. As you can see, the probe is still on. Now for the last one, it's gonna be on, and the probe is going to be off. So let's on both. Let's on switch 2. As you can see, the probe is now off. Now this is for the NAND gate truth table using diode as switches. Now for the next one, it's XOR gate or exclusive gate. Now for the table, it's here. Let's start simulating. So first is off, and the probe is still gonna be off. Let's switch off switch 1 and switch 2. And this is using combination of diode and transistor to be exact. So let's off switch 1 and switch 2. As you can see, the probe is now off. Now for the second one, it's gonna be switch 1 is off and switch 2 is on. It's gonna be on. So let's turn on switch 2. As you can see, the probe is now on. So for the third one, it's good. Switch 1 is on and switch 2 is off. So let's turn on switch 1 and turn off switch 2. As you can see, the probe is now on again. Now for the third one and last one, it's going to be on, and it's going to be off. So let's turn on switch 2, and switch 1 and switch 2 are now turned on. And as you can see, the probe is now off. Yep, the probe is now off. So now that's for the XOR logic gate using diode and transistor as switches. So now for the last one, this is called X X XNOR gate or exclusive NOR gate. So this is the circuit for XNOR gate using diode and transistors as switches. So let's demonstrate. Now the circuit now is simulating. So first, it's going to be off. It's 0, 0, 1 here. So let's turn off switch 1 and switch 2, and the probe is going to be on. So let's turn it off. Turn off. As you can see, it's now off. I mean the switches are now off, but the probe is on. So for the second one, let's turn on switch 2, and the probe is going to be off. let's turn on switch 2. As you can see, the probe is off. So for the third one, let's turn on switch 1 and turn off switch 2, and the probe is still going to be off. So first let's turn off switch 2 and turn on switch 1. As you can see, the probe is off. And now for the last one for the X on pin is on, and the probe is going to be on. So now let's turn on switch 2, and as you can see, uh, switch 2, when all of the switches are on, the probe is on. So that's for the X on gate using diode and transistor as switch. So now what did I learn in this activity? I learned how the diodes and transistor works when it comes to logic gates. It was actually a good experience for me because I'm learning more, and it was also a hard experience because I have less a bit of a less knowledge on using diode and transistor for doing the logic gate. So it was hard, but I managed to and work on this properly, and I learned a lot. And thanks to this activity, I'm learning more. So that's all. Thank you.